Let's start. Answer your attendance. Afla, Anjana,
Present, Miss.
Amaya,
Present, Miss.
Atulya, Drishya, Jyotish,
Present, Miss.
Karthik, Kavya,
Present, Miss.
Nachiket,
Present, Miss.
Neeraj, Rangeet,
Present, Miss.
Vaishnav, Anjali, Shruti.
Present, Miss.
Who has joined now? Karthik?
Present, Miss.
Okay. Atulya?
Present, Miss.
Atulya is there? Drishya? Drishya is there? No. Okay. So we will continue with our topic. So we have seen IPv6 addressing scheme. You can notate it in two ways. It is 128-bit long, and you can notate it in two ways. One is the binary representation, and the other one is the hexadecimal colon notation. Okay, so I have told after each 4 hex digits, you have to put a colon and then separate the digits. Now you can abbreviate in more compact way. That is, abbreviated version is there and more abbreviated version is there. Now we will just see an example how we will be expanding an address to its original address. Now suppose you are having an address as it is shown in the slide. 0 is to 15, double colon, 1 is to 12 is to 1213. So if an address of similar type is given for you, how will you identify the original address? How will you identify the original address? So what you have to do first is, don't read the things, you will be getting confused. So first you understand you have got 32 hex digits, right? So what you have to do is put X, 32X you have to put it, and you have to put a colon after each 4 hex digits. So that is the representation. I have told IPv6, it is 32 hex digits are there. So after every 4 hex digits, you have to put a colon. Now replace the X with the corresponding value what is given in the question. Okay, so the first byte hex value, what it is given, it is 0, right? And the next, I mean, each bytes is given, so 0 is to 15. I have just stopped it. Now start it from, you have a double colon there, so stop it there. Now go to the last end. So you put that 1, 2, 1, 3 in that first group, I mean the last group. Then 12 beyond that. Then 1 beyond that. Then after that, how many zeros you have to put it, or how many hex you have to fill it. So that many zeros you have to accommodate it. So that is how you are finding the original address. So how you have to find the original address, if a double colon is given in the address scheme is, you have to write it down. The first, I mean the 32X, you have to just write it down. You put a colon after 4X, that is hexadecimal, 4 hex points. Then replace the corresponding hex digits depending upon the question. So if where the double colon is there, stop it there and go to the extreme right end. Okay, fill it that and find out how many X are not marked. So that many zeros you have to put it in that space. Okay, so the original address will be 00000015. Then how many zeros you have to put it? That is 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 hex digits you have to put it. Okay, then the remaining values will be coming. Understood how you have to put, make the address original, I mean some address is given and you have to find out the original address. Okay, now I have told the one IPv6 address is 128-bit long. Okay, so what is the address space in IPv6? What is the total number of address space in IPv6? How much it will be? Can anybody answer? How many address space you will be getting here in IPv6?
128 bits.
That is 128 bits you have. I'm asking about the address space. The total number of addresses available. It is? How you found out in IPv4? How many bits were there? IPv4? Yeah, Atulya, you can answer. How many bits were there in IPv4? IP addresses of how many bits?
32.
32 bits. So what was the total address space?
2 raised to 32.
2 raised to 32. Similarly, IPv6 is 128 bits. So what is the total address space? It is 2 power 128 addresses. You just imagine how many addresses are available. Okay, so 2 power 128 address space is possible in IPv6 addresses. Okay, now what you have to study is about the types of address in IPv6. When we were dealing with IPv4, we have seen unicast communication, multicast communication. Now, which classes were responsible for unicast communication? Or which class made use of unicast address key? Karthik, you can answer. Which classes in IPv4 make use of unicast addresses? Yeah, tell. Which all classes is meant for unicast communication? Karthik is there or not?
No, sir.
Yes, tell. You were there in the class? You were absent, right? I think so. Okay. Then you will be answering. Amaya, you can tell.
Class A.
Class A,
Answer.
Class B,
Class B.
Class B, and
Class C.
Class C. Okay, so the three classes, Class A, B, C, they were meant for unicast communication. Unicast means one-to-one, one source to one destination. Okay, similarly, IPv6 also, they defines a single computer. The unicast address, it defines a single computer. Okay, so if the unicast address is present, it will be delivered only to the specific computer. Now, you will have two types of unicast address in IPv6. One is geographically based unicast address. The other one is provider-based unicast address. So two types of unicast addresses are there in IPv6. One is geographically based and the other one is provider-based. So a normal host, they make use of this provider-based unicast address. Now, what is the frame format or the address format of this provider-based unicast address? Now, that is being shown in the slide. Okay, so that is the address format of provider-based. Now, it has got various fields. You just remember all this case because in some question paper, they were asked what is the difference of multicast addressing in IPv6 and IPv4. So you should be able to remember what is multicast address, what is unicast address, etc. Okay, so the different fields in provider-based unicast address, the first field is the type identifier. The first field is the type identifier. Type identifier is nothing but it is a 3-bit field. It defines the address. It defines the provider-based address. Okay, so the first field is the type identifier. Now the second field is called it as the registry identifier. Registry identifier means it indicates the agency that has registered the address. This is a 5-bit field. So the second field is nothing but it is a registry identifier that is of 5 bits, and it indicates the agency that has registered the address. Now the third field is the provider identifier. Provider identifier is, it is variable length. It is nothing but it is of 16-bit length. Now that identifies the provider for internet access. Who is the provider from where we are getting the internet access? That is defined in the third field. Now the fourth field is the subscriber identifier. So if an organization, if it subscribes to the internet, you will be subscribing it to a provider, and that is assigned as the subscriber identification. And the total length will be of 24. Okay, now you have got the subnet identifier. So each subscriber, they can have different subnetworks, and that is identified, that is specified in the subnet identifier. And the total length will be 32-bit. And the last field is nothing but the node identifier. It identifies the node that is connected to a subnet. And the total length will be 48-bit. So you just understand what is the address format of unicast address in IPv6. You have different fields called the type identifier, registry identifier. At least you write these names. You have different fields like type identifier, registry identifier, provider identifier, subscriber identifier, and subnet identifier, and the node identifier. Okay, so this is about the unicast addressing in IPv6. Now, similarly, as we seen in IPv4, they had a class for multicast addressing, multicast communication. Now, which was the class for multicast communication in IPv4? Who will be telling? Which class is meant for? Class D.
D.
Right, yes. Class D was meant for multicast addressing. And here also in IPv6 also you have multicast address format. They are used to define a group of hosts. Multicast address cannot be a source address, it can be only a destination address. That means a group of hosts. One information is passing to a group of hosts, and that is done with the help of multicast addressing. So if a packet is sent to a multicast address, it should be delivered to each member of the group. So you have a group, you have many members in that group. So whatever packet you are sending from the source side, it should reach to each member in that group. And that is done through the multicast addressing scheme. Okay. Now what are the various fields in this multicast addressing? The first field, the all ones, that is the 8 bits, that denotes the multicast, a multicast address. Now the second field is the flag field. It defines the group address. It can be either a permanent address or it can be a transient address. So 4 bits are meant for that. Now the third field, it denotes the scope of the group address. Okay, and finally the 112 bits are used for the group ID. So you should be able to remember what is the difference of multicast address in IPv4 and in IPv6. So just remember the frame format you will have if the multicast address are used to define a group of hosts. So a group, to each member of the group, the packet must reach. Now, what is the address formatted IPv6? You have the multicast address. So that is the type identifier. If it is all ones, you should understand that it is a multicast address. That is the identifier used for multicasting. Okay, now the second field is the flag field. It defines the group address. It can be permanent or transient. Now the third one is the scope that you are going to see as reserved addresses in the next slide. Okay, now this IPv6, it has got some reserved addresses also. Reserved addresses are of 4 types. One is unspecified, loop back, compatible, and mapped. Unspecified, loop back, compatible, and mapped. So unspecified address. There in class E, it was meant for reserved use, reserved purpose. Okay, it is reserved for some other specific purposes. Similarly, IPv6 also supports reserved addresses. You have 4 different types. One is unspecified, loopback, compatible, and mapped. Now, an unspecified address, it is used when a host does not know its own address. What it will do is it will send an enquiry to find its address. That is the meaning of unspecified address. If I don't know my address, I should know somehow know what is my address. So I will send an enquiry. So that type of address is called it as the unspecified address. Second type is called it as the loopback address. So loopback address is used to test itself without going into a network. Before reaching the network, I have to test myself. So I'll make use of an addressing mechanism. So that is called it as the loopback address. Now the third one is the compatible address. It is used if you have a transition from IPv4 to IPv6, you will make use of this compact. So just remember, you don't have to study all these fields, what are the datas and all. You just remember what is unicast address in IPv6, what is multicast address. At least remember those fields name. That is more than enough. Okay, and the reserved addresses. Okay, so far we were discussing about the 2 IP addressing schemes. One is version 4 and the other one was version 6. Right. Now we move on to the very, very important topic, that is nothing but the network layer protocols. When we were discussing it, you can hear me? Amaya?
Voice cut down the
Sound breaking.
Okay, there is some network problem in my house. Okay, now is it clear? Can you hear now?
Yes.
Okay, right. Now, in the first module, we were dealing with the internet model or the TCP/IP model. So hope now you remember what is the frame format of the TCP/IP, how you have defined in what is the protocol that is used in each layer. Hope you remember, hope it is there in your mind. Now, remember the protocol. What protocols of TCP/IP in the network layer? Just remember, what are the, how many layers you have specified? What is the first layer, what is the second layer, and what is the third layer? Third layer we are dealing with, that is nothing but the network layer. And I have told you have got very many different protocols in that. The main protocol is which protocol?
Break down.
Presenting it. No sound. Oh. Okay, voice. I don't know, some problem with the net connection. Okay, tell me, what is the protocol that you studied in the network layer of TCP/IP?
ARP.
Yeah, what was the main one? You have sub protocols. What was the main protocol?
TCP.
It is denoted as what? Just remember the layers in TCP/IP. You have written your assignments, you have written your test. How you have denoted it? Amaya, you tell.
Inter-networking protocol.
Yeah, Internet Protocol, IP, Internet Protocol. And you have got other sub-protocols like ARP, RARP, IGMP, etc. Don't forget all these things because that is the whole module dealing with the continuation of the first in TCP/IP is the networking protocol or the internet protocol. Now you can just see in the slides. This is the format what you have learned in your TCP/IP protocol suite. So IP version 4 was the main protocol, and you have other sub protocols like ARP, RARP, IGMP, and ICMP. Now, considering this, yes,
full kittunnilla.
Let me reconnect once more. You be online. I'll just reconnect it once more. Okay. Okay. So what I told is the internet protocol is the main protocol in the network layer of the TCP/IP. Okay. Now, what type of network it was actually? You have seen it is nothing but it is a packet switch network. The internet at the network layer is nothing but it is a packet switch network. I know, I hope you know what is the difference between circuit switching and packet switching. Okay, so in in network layer, it is nothing but it is a packet switched network. So two types of approaches are there in packet switching. One is called the datagram approach, and the other one is called the virtual approach. So first one is the datagram approach. So that is the approach that is used by the packet switching in network layer. And also I have told you have got two types of services. One is connection oriented service and the other one is the connectionless service. So what type of communication is happening in the network layer is nothing but it is a connectionless oriented service. So in connectionless, each protocol or each packet don't have a relation to another packet. I have told you have got the whole message. The message is divided into packet, and the protocol, it treats each packet independently, each the other packets. Okay, now it is not you'll be studying in the next module. The shortest path they will be selecting and they will be reaching the destination. So it is a connectionless datagram approach. The protocol, it uses a connectionless datagram approach. So IPv4 is unreliable and connectionless datagram protocol. IPv4 is unreliable and a connectionless datagram protocol. So what is the meaning is that they will be getting the data from the data link layer. So each packet, the frame data link layer, you will call each data bits as frames, and they will be passing it to the network layer. Network layer, they will call it as packet. So once it reaches the network layer, what it does is it does its maximum to send the packet to the correct destination. It is a connectionless service. But so the meaning is you don't have any guarantee that the packet reaches the correct destination. Okay, but so the meaning is IPv4, that protocol, it will do its level best to transfer the packets to the destination. But there is no guarantee based on that. Okay, so that is the importance of internet protocol, IPv4 protocol. So it is a unreliable connectionless datagram protocol. Datagram, it is one approach in packet switching. Connectionless is the type of service that it is making use of. So connectionless service, the network layer protocol, it treats each packet independently. Each packet is not having any relationship between it to the other packet. It may or may not follow the same path to reach the destination. Okay, now what you have to study is the datagram format. What is the packet format in network layer? So this is the datagram format that we will continue it in the next class because the time won't be sufficient to explain all these fields. Okay, so just remember, started with the internet network protocol, that is nothing but the internet protocol, that is IPv4. It is nothing but it is a connectionless datagram protocol. Two terms you have to remember, what does connectionless means and what does datagram means. Okay, so the packet in this thing is called it as the datagram packet. Okay. Now the next class we will be dealing with what is the format of that packet. Once it was asked in the question paper, explain the datagram format in IPv4 and IPv6. So you have to study this. Okay. So I'll stop the topic now and just we will do a revision of the first and the second module. So started with IPv6, classless addressing today, and also IPv6, what is how many bits it has got, what is the address space of IPv6, and what is the main protocol at the network layer, okay, of the TCP/IP protocols. I hope you understood the topics. Okay, now we will just refresh what we have studied in the first and the second module, so it will be useful for your series test. Prepare well for the series test, not only my subject, all the subjects, you prepare nicely and get good marks. And write neatly so that all the staffs can read what you have written properly. Okay. Atulya is there? Drishya?
Yes, yes.
Okay. Then Neeraj? Vaishna and Vaishnav?
Miss Neeraj.
Neeraj. Vaishna and Vaishnav is there.
Mr.
Anjali? Okay. Right. Now, I'll be asking some questions you have to answer. What are the different transmission modes in data communication? What are the different transition modes in data communication? Kavya can answer.
Serial, parallel,
Yeah, then
asynchronous.
asynchronous, synchronous. That is just the classification of what? Serial or parallel?
Serial.
Serial. Okay.
Serial.
Then, okay. Then, which type of mode you have studied? Then what are the other modes? Transmission modes.
Va-
Some duplex communication you have studied?
Simplex duplex.
Full duplex? Yeah,
Half duplex. Half duplex.
half duplex. Now, what is the difference between that?
In simplex, we can transmit. Only we can transmit,
Hmm.
or otherwise we can receive. Half duplex,
Okay,
both transmission, receive, reception.
okay.
Full duplex, at
So
a
when you
time
are
we can transmit.
explaining that, you should draw the figure and then write 1 or 2 sentences. Okay. So if it is asked in the question paper, you have to answer it accordingly based on the marks. Now, what do you mean by topology? What do you mean by topology? What are the different types of topologies available? Who will be answering? Ajmina. What is topology? Ajmina is there?
Yes, miss.
Yeah, answer.
Mesh,
What is?
mesh topology,
I'm not asking the types. What is topology? How will you define? Topology is
uh,
what it denotes.
physical arrangement
Hmm.
of
Physical?
arrangements of
Hmm. Arrangements of?
links,
Physical arrangement of links.
നെറ്റ്വർക്കിലുള്ള
Hmm. How the network is laid out. Graphical representation. Right? You can denote that, you can call it as topology. Now, what are the different types of topologies?
mesh topology, star topology,
Hmm.
bus topology, and a ring topology.
Topology. So if topology asks, you should first specify what is the definition for that, what are the different types, and if it is asked, you have to write it. If it is, suppose, if you are writing bus topology, write what it means actually. Now, what are its, just draw a diagram. What are its merits? What are its demerits? So if a question is asked like that, you should be able to represent it like that. Okay, and it is based on the mark. Look onto the mark and answer it. Okay, now what are the 2 network models available? Karthik, what are the 2 network models? Karthik is there?
OSI അതല്ല
OSI and
പിന്നെ മറ്റേ വേറെന്തിനാ
OSI, what is the expansion of that? O stands for what? Tell, make it fast. Karthik, OSI means ഒന്നും ആരും പഠിക്കുന്നില്ല, മറ്റന്നാൾ പരീക്ഷയാ. OSI, Drishya, you can answer.
Open system
Open
interconnection.
system interconnection. So if you want to communicate, the 2 devices, if they want to communicate, they make use of the structure, called the OSI model, how the processing is taking place between 2 devices. It opens communication between 2 devices. Okay. Now, whatever be the underlying architecture, you can communicate, communication can happen between 2 devices. Okay. One is the OSI model and the other one is, which one? The other one was?
TCP/IP.
TCP/IP or the internet model. Now, which are the 7 layers in the OSI model? You might be asking. Vaishna, you can answer. Which are the 7 layers of the OSI model?
Physical layer,
Yeah.
data link layer,
Yes.
network layer, transport layer,
Hmm.
section layer,
Okay.
session layer, application layer.
Session, presentation, and application. Which is the layer 7? Layer 7 is?
Application layer.
Application layer. So don't confuse. Layer 7 is the application layer and the layer 1 is the physical layer. Okay. Now, what are the different functions of those layers? Rangeet can answer. What is the function of physical layer? What is the function of physical layer? Rangeet is there? Okay, why should, okay, Rangeet has unmuted. Yeah, tell. What are the duties or the responsibilities of physical layer? What is the main responsibility of physical layer?
Transmit data. Data transmission.
Confidence or kudi para അറിയാവുന്ന കാര്യങ്ങള്.
Data transmission.
Clear ആയിട്ട് പറ.
Transmit data in the medium.
Yeah, it converts, it makes the data into a suitable form to transmit it through the medium. And also it controls the transmission medium. Now in the second module about the physical layer, what all topics we have covered? Second module, two layer പഠിച്ചു. On the physical layer, the other one is the data link layer. So physical layer, what you have concentrated?
Transmission media.
Yeah, transmission medium. Now, what are the two type of mediums? Generally, how you can classify it?
Wired and wireless.
Wired and wireless, or guided and unguided. Now, what are the various guided medias? Neeraj, what are the various? Neeraj on top. Vaishnav, you can answer.
Hello.
Tell.
Twisted pair cable, coaxial cable, fiber optic cable.
Very good. Twisted, coaxial cable and fiber optic cable. Now, when it is asked, you should write what are the specifications, what are the importance of twisted pair, and what are the advantages and disadvantages if it is there. Okay. And fiber optics also, sometimes the advantages, disadvantages specifically it will be asked, so you will be able to write it. Okay. Then, which was the second layer 2 of the internet model? Whom I should ask? Ajmin, Afla has answered, right? Anjali, you can answer. Which was layer 2 in the internet?
No, sir.
Which layer is the second layer of the OSI or the TCP model? Layer 2. Anjali. Okay, Drishya can answer.
Data link.
Data link layer. Now, what are the responsibilities of data link layer? Drishya. What are the responsibilities of data link layer? Make it fast. What are the responsibilities of data link layer?
Framing.
Framing, yeah.
Framing.
Yeah.
Physical addressing.
Yeah.
Flow control.
Yeah.
Error control.
So remember, what are the different types of framings available? Variable and fixed. What is bit stuffing, byte stuffing? Then gone with flow control, the two methods, stop and wait and sliding window. What is error control? You have 3 again. ARQ mechanism is added to the flow control. That is nothing but the error control. You have stop and wait ARQ, Go back in ARQ and selective repeat ARQ. Okay. Then you have studied a protocol in your second module that is nothing but HDLC. Now, what are the different types of frames in HDLC? In shortly, how you can tell it? What are the different types of frames? Yeah, I frame, S frame, and U frame. Okay. So all the best for you. Attempt all the exams well. So wishing you all the best. Okay. Thank you. The other staff has joined. So I will end this.
Thank you, Miss.